Good morning, class. We are looking at Chapter 3 Derivatives, Section 3.1 Derivatives and Rates of Change. So in this chapter, we cover derivatives and rates of change, the derivative as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the log functions, differentials. So recall, limits of functions at finite numbers, finding limits by numerical and graphical method. This says the limit of f of x as x approaches a equals L. The limit of a sub n as n approaches infinity is equal to L. We say that a sub n converges to L. If it's infinity, negative infinity, or does not exist, we say the sequence diverges. To find limit, simply plug in and observe. Let's look at all these three cases. We are interested in the limit of f of x as x approaches a. So as we approach a from the left and right, so from the left, from the bottom, and from the right, from the top, and we approach L from the bottom and the top, and in all cases, the limit of f of x as x approaches a exists and it's equal to L. The difference is this is also f of a equals to L, making it continuous at x equals a. This one f of a equals b, which is discontinuous at L, and this is f of a is missing in general. So that's as far as the graphs are concerned. Horizontal asymptote has a specific definition. Horizontal asymptote HA of the curve y equals f of x has the equation y equals L if the limit of f of x as x approaches negative infinity is L, or the limit of f of x as x approaches infinity is L. VA or vertical asymptote, the limit of f of x as x approaches a is plus minus infinity, or as x approaches a from the left or right, and then it gives rise to the equation of a vertical asymptote, x equals a. One-sided limits. A function has a limit at a if the limit of f of x as x approaches a from the left and right are the same, then the limit of f of x as x approaches a exists and it's equal to L. Definition of a continuity indicates that the limit of f of x as x approaches a must be equal to f of a. And now the new section 3.1 derivatives and rates of change. Given y equals f of x and point a comma f of a, the slope of a secant line PQ, P has coordinates a comma f of a, Q has some other coordinates such as x and f of x. M of PQ, you have 2 points, rise over run, delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, there are various ways that we can write this. For example, if we go with this, we would write f of x minus f of a is the rise, x minus a is the run, so f of x minus f of a over x minus a. If we go with this one, where this point has coordinates a f of a, and we go the distance of h, which means the run is a plus h minus a, simply h, and the rise is f of a plus h minus f of a. And this is the formula for that. If we call this point b, therefore this becomes f of b, and we can say f of b minus f of a over b minus a, all of which are referring to one thing and one thing only, rise over run. And we also call them the difference quotient. Normally, this is the one that is called the difference quotient. So I want to make sure that everybody's comfortable with the concept. There's really nothing brand new here, different ways of writing them. Now, as PQ, which represents a secant line, as Q gets closer and closer to P, the secant line, the blue line, becomes the tangent line, the red line, and therefore the tangent line is the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. How do we find the slope of a tangent line? which is also known as instantaneous rate of change at a specific point A. M of tangent line is the limit of M of PQ, the secant line PQ as Q approaches P. If you look at this one, limit of f of x minus f of a over x minus a as x approaches a. If you look at this one, the limit of f of a plus h minus f of a over h as h approaches 0 as this distance becomes 0. They all mean the same thing. Again, it's important to understand they all refer to the same thing, everybody. And M of tangent line or f prime of a, limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0. Now, we remember that in order to find the equation of a line, there are three different ways. Standard form, ax plus by equals c. Point slope, y minus y1 equals m times x minus x of 1. And slope intercept form, y equals mx plus b. When you solve for y, becomes the slope intercept form, which is unique. Now, if you look at this point, a comma f of a, and you want to find the equation of a tangent line at this point, you got to go with the point slope, y minus y1, that means y minus f of a equals m f prime of a, x minus x of 1, x minus a. Now, do I have to memorize this formula? No, I highly recommend you just use the elementary algebra point slope, and you're in good shape. Just plug it. So rates of change, the difference quotient, rise over run, delta y over delta x, f of x of 2 minus f of x of 1 over x of 2 minus x of 1 is called the average rate of change of y with respect to x. So you have 2 points. There are different ways of approaching it. This is another approach. Over the interval of x of 1 to x of 2, and can be interpreted as the slope of a secant line, the blue line, PQ. We recognize the following limit as the derivative of f prime at x sub 1 or f prime of x sub 1. Various ways of looking at it. Instantaneous rate of change, limit of delta y over delta x as delta x approaches 0. This distance, the run, can be delta x or h. Limit of f of x sub 2 minus f of x sub 1 over x sub 2 as x sub 2 approaches x of 1 as x sub 2 approaches x sub 1. If we go back to the previous page, the limit of f of x minus f of a over x minus a as x approaches a, and the limit of f of a plus h minus f of a over h as h approaches 0. They all mean the same thing. So the derivative f prime of a is the instantaneous rate of change of y, f of x with respect to x when x equals a, and normally we go with this format. It's pretty straightforward, everybody. So now let's actually look at some examples to make some sense out of this. Average rate, the slope of a secant line. Instantaneous rate, the slope of a tangent line at a specific point. Find the average rate of change of f of x equals x squared minus 3x as we go from 2 to 4. So 2 points given, that means average, even if it's not mentioned. So simply put, f of average is f of b minus f of a over b minus a. In this case, f of 4 minus f of 2 over 4 minus 2. So what do? We plug in. We plug in 4 here. We get 4 squared minus 3 times 4. Then we plug in 2 here, minus 2 squared minus 3 times 2. And the denominator, of course, 4 minus 2 is 2. So we have 16 minus 12, which is 4. 4 minus 6, which is negative 2. Now 4 minus minus 2 becomes 6 over 2 equals 3. So we have 2 points 2 points given, and therefore it's the average rate. However, in this case, we want to find the instantaneous rate of change of f of x at x equals 4 because 1 point is given. So again, we have 2 points here, 1 point here. And that's the difference between the two. And we are going to look at one of those definitions. In fact, I'm going to start with this, and later on, I'm going to try the second method for practice. So f prime of a equals limit of f of a plus h minus f of a over h as h approaches 0. So a must be replaced by 4. So f prime of 4 is limit of f of 4 plus h minus f of 4 over h as h approaches 0. So what is f of 4 plus h? 4 plus h squared minus 3 times 4 plus h minus f of 4. F of 4 was already calculated as 4. Let's write 4 squared minus 3 times 4 just in case, but this is already 4. We know that. Okay, everybody. So what is this? Reminding everyone, this is of course 4, reminding everyone that a plus b squared is a squared plus 2ab plus b squared. So 4 squared is 16, plus 2 times 4 times h is 8h plus h squared. So that's this part. Minus 3 times 4 plus h, minus 12 minus 3h. And this one we don't, I mean, we remember it's 4, so minus 4. Now notice 16, negative 12, negative 4, they add up to 0. Then we have h squared in the numerator as well as 8h and minus 3h that they add up to 5h. We factor the h out. We can drop the common factor of h from the top and the bottom. So the limit of 5 plus h as h approaches 0 equals 5. And so having said that, again, we can plug in. What I want to emphasize is this. If you don't have the limit, 5 plus h remains 5 plus h, not 5. So it's important to know the limit sign must be there. Now, we don't have to do the second method, but I want to do it for the purpose of practice. F prime of a is limit of f of x minus f of a over x minus a as x approaches a, and of course, a is 4. So what is f of x? X squared minus 3x. What is f of 4? You can calculate it, or we've already done that. 4, just put 4 there. Plug in, you get 0 over 0. And remember, it is the 0 in the denominator that creates a problem, and denominator has a factor of x minus 4, so the top must have a factor of x minus 4 as well, and that helps. You want two numbers, the product is negative 4, the sum is negative 3, we get minus 4, positive 1, and the common factor of x minus 4 you drop, and now if you plug in, you get 5, and that's exactly what we had here, and we are done. And that's really the key. Both methods will result in the same thing. There's really not much to it, everybody. But it's worth noting that when we learn both, one may be easier than the other. Most of the time, later on when we look at the f prime of x, this is used more often. And of course, f prime of x, and they put the x here. Here's example 2. Find an equation of a tangent line to the parabola y equals x squared at the point 1, 1. Now, we want to come up with the equation of a tangent line. which means we need two things. We need a pair, it's given. By the way, if they give you x, that's good enough because, if, for example, x is 1, so is y. If x is 2, y is 4. If x is 10, y is 100. Not a big deal. So in this case, a equals 1. The function is x squared, and we are going to find the equation of a tangent line one way, and then we practice with the second method. So I'm going to go with this method. M equals f prime of a, limit of f of x minus f of a over x minus a. And of course, we are interested in f prime of 1. So the limit of f of x minus f of 1 over x minus 1 as x approaches 1, all you have to do, replace the f of x with x squared and f of 1. Either plug it in or just replace it with 1. Clearly, if you plug in 1, you get 0 over 0. So the technique is factoring. The numerator is a squared minus b squared, reminding you that a squared minus b squared is a minus b, a plus b. And this one is x squared minus 1 squared, if you will. It's the same thing, right? So x minus 1, x plus 1. And you can drop the common factor of x minus 1. The limit of x plus 1 as x approaches 1. Now we can replace the x with 1, and the answer becomes 2. Practically, we are done, because now y minus y1 equals m times x minus x of 1. And all you have to do, plug in, and you're fine. Which means y minus 1 equals 2 times x minus 1. And x minus 2, move it, becomes positive 1, 2x minus 1. And again, bear in mind, if you plug 1, it should work, and it does. That means this process is right, has got nothing to do with finding the slope, okay? Now, we're done with that. But let's look at the second method. M is limit of f of a plus h minus f of a over h as h approaches 0, and a is 1. So what is f of 1 plus h? That's 1 plus h squared minus what is f of 1, 1. And this a plus b squared is a squared plus 2ab plus b squared. Therefore, 1 squared is 1 plus 2 times 1 times h, 2h, and then h squared. 1 and negative 1 cancel each other. We can factor the h out from the top, and therefore we can drop the common factor of h. And now, if I plug in h equal to 0, I get the same answer as expected here. So I have the slope, and of course I don't do this again, but you get the picture. So we want to find the derivative, also known as the instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at x equals 5. So we can use one of those definitions. In this case, f prime of 5 equals the limit of f of 5 plus h minus f of 5 over h as h approaches 0. So what do we do? It's very simple. We have to evaluate the numerator, that's all. So plug in 5 plus h, you get 5 plus h squared here, minus 8 times 5 plus h plus 9, minus plug in 5 squared, minus 8 times 5 plus 9. So that would be the numerator that requires simplification. Let's do that. 5 plus h squared, we use the identity that means 25 plus 2 times 5 times h, 10h plus h squared. Then minus 40 minus 8h plus 9. This is 25. This is 40. So minus 25 plus 40 minus 9. You could simplify the second parenthesis, and that may be a better idea. But the reason I didn't pay attention to what I'm going to show you, 25 cancels out negative 25. Minus 4 plus 40. Positive 9, negative 9. That's why I did that way. But in any event, in the numerator, you have h squared, and you have 10h and minus 8h that they add up to 2h. We factor the h from the top and the bottom, and h drops. We get the limit of 2 plus h as h approaches 0. If we plug in now, we get 2. So very straightforward, everybody. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the average velocity of object from 2 to 4 seconds? Well, again, just as before, elementary algebra, total distance over total time, d equals rt, if you recall. That's the same concept here. Therefore, the average is s of t sub 2, that means s of 4, minus s of t sub 1, that means s of 2 over 4 minus 2. So let's plug in 4 and 2. The denominator obviously is 4 minus 2, 2. So let's plug in 4. We get 2 times 4 squared minus 5 times 4 plus 40. Minus, let's plug in 2. 2 times 2 squared minus 5 times 2 plus 40. So 2 times 4 squared, this is 16. This is 32 minus 20 plus 40. This is 4. So we have 8 minus 10 plus 40. And so this one, 32 minus 20 plus 40 is 52. 8 minus 10 plus 40 is 38. So minus 38. 14 halves or 7 feet per second. By the way, when you do applications, you must always answer with proper units if units are provided. In this case, units of the numerator over units of the denominator, units of distance over units of. What is the instantaneous velocity of the object at 4 seconds? Bear in mind, we are given 2 points, so it's average. We are given only 1 point. It means instantaneous. And we are going to write, we're going to go from f of x, which becomes f of a, to s of t. So v of instantaneous is limit of s of a plus h minus s of a over h as h approaches 0, where a must be the time given, 4 seconds. And so what is s of 4 plus h? We go back to s of t and we plug in 4 plus h. So we get 2 times 4 plus h, quantity squared, minus 5 times 4 plus h, plus 40. And then s of 4, we can do the same thing, or remember, s of 4 was calculated to be 52. So we can use that. Okay. So 2 times 4 plus h squared minus 5 times 4 plus h plus 40 minus S of 4 has been already calculated as 52. So how do we deal with 4 plus h squared? You square a plus b. So this gives you 16 plus 2 times 4 times h. It's 8h plus h squared. You distribute the 2, you get 32 plus 16h plus 2h squared. Then we have minus 20 minus 5h plus 40 minus 52. And again, just take a look at all the numbers. Positive 32, negative 20, positive 40, negative 52. I hope you see that they add up to 0. Now we have 2h squared at top, as well as 16h and minus 5h. These two add up to 11h. So we have 2h squared plus 11h. We can factor the h out. So it cancels out the h in the denominator. Bear in mind, we have a 0 in the denominator that creates a problem. So we are hoping to get rid of it. It happens in this manner. And of course, right now, remember, you have to keep the limit here. So therefore, you can apply the 0 to h, and you get 11 same unit feet per second. Okay, we're going to move on. We want to find an equation of a tangent line to the graph of the function f of x equals square root of x at the given point with coordinates 16 and 4. Again, I want to emphasize, to come up with an equation of a line, you need two things. You need a pair, which is given, and you need the slope. As far as the pair is concerned, they really don't have to give you x and y. X is good enough because 16, if you plug in, you get 4. If they said 20, it's square root of 20. If they said that 25, the square root of 25 is 5. So whatever x is, you can figure out what's y by plugging it. So in this case, we have to come up with the slope, which requires differentiation. And so a is 16, f of x square root of x. And we are going to use one of those. In fact, again, I'm going to use 2 for practice, but for now, m is the limit of f of a plus h minus f of a over h as h approaches 0. So this one we're going to use right now. We are going to replace the a with 16. So we're going to say m is f prime of 16 is the limit of f of 16 plus h minus f of 16 over h as h approaches 0. So what is f of 16 plus h? Is square root of 16 plus h. What is f of 16? You have two choices. Just write down square root of 16 or use 4. It makes no difference. The reason I chose to go with square root of 16 is because what if that number wasn't a perfect square? Let's say it was 17, you would write square root of 17. It gives you the same result. When you plug in h equals 0, you get 0 over 0. So what do? When you get 0 over 0, you use one of your techniques that you learned as far as the limits. Because square root is involved, you multiply by the conjugate. The conjugate of a minus b is a plus b. The conjugate here would be the same thing with a plus sign. And you put it at top and the bottom. Bear in mind, this fraction is equal to 1, and that's acceptable. Also, h approaching 0, the denominator h is a problem. You never distribute, you write them as a product. Now, the product of, so the bottom you write as a product, the product of the top gives you square root of 16 plus h squared minus square root of 16 squared, which is 16 plus h minus 16. These two cancel each other. The numerator is only h. So the limit of h over the square root of 16 plus h plus square root of 16 remains, and you can drop the common factor of h, and the numerator changes to 1. There is nothing else we can do to simplify it further. Therefore, we plug in. Now, if I plug in 0 here, I'll get square root of 16, which is 4, square root of 16, which is 4. They add up to 8. The final answer is 1 over 8. So I have 1 point with coordinates 16 and 4, and I have the slope, and I'm going to use the point slope. Y minus y1 equals m times x minus x of 1. Therefore, y minus 4 equals m, which is 1 over 8x minus 16. And distribute, we get 1 over 8x minus 1 over 8 times 16 is 2, minus 4 is plus 4. We get 1 over 8x plus 2. And I highly recommend you check that 16 and 4 works, meaning this process was right, has got nothing to do with finding the slope. And we are done. But again, for practice, I want to do this with the second method, where f prime of a is limit of f of x minus f of a over x minus a. This is for practice, everybody. So plug in. What do we want? F prime of 16. So the limit of f of x minus f of 16 over x minus 16 as x approaches 16. F of x is square root of x. F of 16, 4. Obviously, if you plug in, you get 0 over 0. And 0 over 0 means we need to use our algebraic techniques. The numerator is in the form of a square root. Therefore, we use the conjugate. A minus b, the conjugate is a plus b. So square root of x plus 4. Put it here. Also at the bottom. Again, this fraction must be 1. So first, what happens to the bottom? Nothing. You keep it as a product because x is approaches 16, x minus 16 approaches 0, and that's a problem you want to get rid of. What happens to the top? Square root of x squared minus 4 squared. You get x minus 16 in the numerator, cancels out the x minus 16 in the denominator. And so you get 1 over square root of x plus 4. You're taking a limit. If you put 16 here, this becomes 4 and 4, 8. So this is the same number that was found here. And that is the slope of a tangent line. Very straightforward, everybody. The next example comes from the review of exam. If you look at the module under Canvas, I have some exam review questions, okay? And they're key, but now we're going to go over that with details. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflowers 8 weeks after planting? A couple of items I want to mention. Number one, this is elementary algebra. There's really not much to. Number two, they said include proper units. Even if they don't say that, you must. Anytime you're dealing with an application, you have to put the proper units, always. So, how tall is the sunflower 8 weeks from now? That is simply f of 8. To calculate f of 8, plug in 8. 6 times 8 minus 1/4 times 8 squared. And again, elementary algebra, basic math. So this is 48. This is 64. And this is 1/4 of that minus 16. We get 32 inches because that's the height, the units in inches. So you always give back with proper units. Part B, find the average rate of growth from the end of week 6 to the end of week 12. Now, as it's been mentioned before, even if they don't say average, what is the rate of growth from week 6 to end of week 12? 2 points in time given. That's rise over run. That's the average rate of y with respect to x. And in this case, delta y over delta x, because f of x up 2 minus f of x sub 1 over x up 2 minus x sub 1, or f of 12 minus f of 6 over 12 minus 6. So I hope everybody pays attention to that and understands that it's really not that big of a deal, and it's just elementary algebra. So the bottom obviously is 12 minus 6, which is 6, not a big deal. The numerator, let's plug in 12 here. So we get 6 times 12 minus 1/4 of 12 squared. Then let's plug in 6 in a bracket and negative in front. 6 times 6 or 6 squared and minus 1/4 of 6 squared. Okay. Let's see what we get here now. Six times 12 is 72. This is 144. 1/4 of it is 36. So we have 72 minus 36. 6 times 6 is 36. This is also 36. 1/4 of it is 9. We have minus 9. Now notice, if we apply the negative here, we get minus 36 plus 9. So 72 cancels out negative 36, negative 36. The answer is 9 over 6, which is 3/2. So this is 36 minus 9 also. And as I mentioned, minus and plus. So they cancel each other. So 3/2 of an inch per week. Please understand the units would be the units of the numerator, change in height, over the units of the denominator, change in time in weeks. So that's what we have. Find the instantaneous rate of growth 10 weeks after planting. Again, reminding you the function was given was 6x minus 1/4 of x squared. Now, again, if they don't mention instantaneous, it doesn't matter because one point in time is given. It means instantaneous rate of change, everybody. So we are going to use one of those formulas. And now I'm not going to use both. I highly recommend you use the other one for practice on your own. So I'm going to use the first one, f prime of a, in this case, f prime of 10 equals limit of f of x minus f of a, that means f of x minus f of 10 over x minus a, that means x minus 10. As x approaches a, as x approaches 10, we want f prime of 10. So let's use that formula. So it's very simple. F prime of 10 equals this limit. The bottom doesn't change. F of x is this function that doesn't change. Let's plug in 10. 6 times 10 minus 1/4 of 10 squared. So in other words, just basically the numerator is something you have to work on. The rest are very straightforward. It's just x minus 10. So what happens here? Let's see. This is 60. This is 100. So 1/4 of that is 25. So minus 25. And 60 minus 25 is 35. All right. So we have 6x minus 1/4 x squared minus 35 over x minus 10, and we're taking a limit. So what is this fraction? It's a complex fraction. Why is this a complex fraction? Because this has 1/4. There's a fraction within a fraction. So the easiest way is to multiply the top and the bottom by LCD, which is. So first, I want to discuss the denominator. X is approaching 10. X minus 10 becomes 0. This is a problem. You never, ever distribute. You write it as a product. Then these two, 24x, these two, the 1/4 goes away, minus x squared, minus 35 times 4 is minus 140. And so we're going to work on this numerator. First, I'm going to put it in descending order. That means minus x squared comes first. Secondly, we don't want a negative here, so I'm going to factor out the negative. This becomes minus parentheses x squared minus 24x plus 140. All of this is to get this ready for factoring. And so you want two numbers. The product is 140, the sum is negative 24 on the one hand. On the other hand, you know x is approaching 10, x minus 10 is 0. Therefore, you're hoping the top has a factor of x minus 10, so you get rid of that, and it does. The two numbers are negative 10 and negative 14. Now, please understand this negative sign, I kept it outside. And x squared minus 24x plus 140, I factored into x minus 10 times x minus 14. I haven't touched the denominator, and now we have a common factor of x minus 10. This negative sign remains, and this is the limit as x approaches 10 of x minus 14 over 4. We're going to plug in 10. 10 minus 14 is negative 4. Negative 4 over 4 is negative 1. The negative in front makes it positive 1. So f prime of 10 is positive 1. Positive 1 what? Inch per week. Units of the numerator over the units of the denominator. So f prime of 10 is 1 inch per week. What does this mean? Explain the meaning of your answer to part C. That means 10 weeks after, or on week 10, the sunflower is growing at this rate. So on week 10 or after week 10, The sunflower is growing at a rate of 1 inch per week. Please understand, this is positive. So we say it's growing. If it was, or increasing in essence. But if it was negative, we would just use the word decreasing and keep this as 1 if it were negative. So growing or increasing indicates the fact that this is positive. Decreasing indicates the fact that it might be negative. In this case, of course, it's positive, and we go with growing or increasing. Example 7. Suppose that the ball is dropped from the upper observation deck of CN Tower 450 meters above the ground, and the formula is S equals F of t equals 4.9 t squared. What is the velocity of the ball after 5 seconds? How fast is, or what is the velocity of the ball traveling when it hits the ground? And so what happens here, they're asking for the instantaneous velocity, which has this formula. And if you look at part A is 5. What about part B? We have to go through the process, and I'll show you to find the value of A for that. So if I want to go with that, and I replace the A with 5, so I'm going to start with that. If I replace the A with 5, then I have to do it 2 times. In fact, if the question is asking what is the velocity of the ball after 2 seconds, 3 seconds, 4 seconds, then I have to keep repeating the process again and again and again. Instead, this is a good transition to the next section, which is finding the derivative function. Instead of saying that I want v of a, you're going to ask for v of t. And in this case, I'm going to stick with a for now. And I'm not going to change the a to 5. I'm going to keep it as a. When it's finished, it's a function of a. And then you see the advantage as we go through that. But for now, we're going to keep it as a. Therefore, f of a plus h would be 4.9 a plus h quantity squared minus f of a would be 4.9 a squared. The limit remains, the h in the denominator remains. Clearly, if you replace the a, h with 0, these two are identical with the negative in between, they cancel each other. So you do get 0 over 0, and that means some sort of a technique. The technique is to simplify the numerator. This is a plus h squared, so following that, this is a squared plus 2ah plus h squared. And at the same time, I'm going to take the common factor of 4.9 out. So this is a squared plus 2ah plus h squared and minus 4.9 to a squared. 4.9 you take out, you get negative a squared, and therefore we can cancel out the a squared and negative a squared. So in the numerator, we have 4.9 times 2a plus h squared. And from the top, I can take the h out. If I take the h out, I get 4.9h. This is 2a, this is h. And the reason I factor the h out, so I can drop the common factor of h from the top and the bottom. So I get the limit of 4.9 times 2a plus h. And there's nothing else I can do, so I'm going to replace the h with 0. You have to keep the limit, otherwise you can't replace the h with 0. Now the limit says you can replace the h with whatever this number is, happen to be 0. So 2a times 4.9 is 9.8. And notice the final result, v of a is 9.8. A is a function of a. So v of a is a function of a, which means for part A, because the value of a is 5, I just replace the a with 5, and I get v of a 5 is 9.8 times 5, which is 49 meters per second. If I had replaced the a with 5 here, I went through the process, I would get to the same answer. However, for this part, I have to find the t first. Let me do that. To find the t, remember, it's going to travel 450 meters and follow this formula. So it's going to cover 4.9 t squared with 450, so they must be. We're going to divide by 4.9 to get t squared. 450 divided by 4.9 is about 91.837. T is the square root of this number and positive only, so about 9.583. I'm going to stick with 9.6 roughly. Now, if I had put f of 5 plus h for part A, now I would have to replace the A with, let's say, 9.6, and I go through the process again. But I don't have to, because I kept it at A, V of A is 9.8, and so V of 9.6, replace the A with 9.6, and their product is 94.08 meters per second. It makes it a lot easier, a lot faster, and that's what we are moving towards in the next section, the differentiation function, the derivative function.